Good morning, class. We are looking at double angle and half angle formulas, section 7.3 of OpenStax. So we looked at trigonometric equations, identities, sum and difference formulas. We're going to look at double angle and half angle formulas. We're going to use double angle formulas to find the exact values, to establish identities, and we're going to use half angle formulas to do the same. Again, reminding you of the unit circle. Trigonometric functions are periodic functions. They are all odd except cosine and secant and fundamental identities. We added sum and difference formulas. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Sine of alpha minus beta, basically this changes to negative. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Cosine of alpha minus beta, this changes to plus. It's important to remember these formulas. Tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. If we go with tan of alpha minus beta, the sign at the top and at the bottom, they both change. So it becomes tan alpha minus tan beta over 1 plus tan alpha tan beta. Now, for the double angle and half angle formulas, I'm going to give you the summary, and then we will look at the proofs. For example, sine of 2 alpha is 2 sine alpha cosine alpha. Cosine of 2 alpha, there are three ways to write them. Cosine squared alpha minus sine squared alpha, 2 cosine squared minus 1, 1 minus 2 sine squared. Three different ways. Tangent is 2 tan alpha over 1 minus tan squared alpha. We can establish sine squared alpha based on these formulas to be 1 minus cosine 2 alpha over 2, sine squared alpha over 2, 1 minus cosine alpha over 2, as I mentioned, and cosine squared alpha is 1 plus cosine 2 alpha divided by 2. Now, the difference between these two, if you use alpha here, you need 2 alpha. If you go with half of that, then you need alpha. So alpha here, you need 2 alpha here. If you use half of it, you need alpha here. So very similar, but establishing this half angle really comes from this. Tan squared alpha is 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. Now, if we change this alpha to alpha over 2, then we change the 2 alpha to alpha. So if sine squared alpha over 2 is given, then sine of alpha over 2 is plus minus the square root of that. From here, cosine of alpha over 2 is plus minus 1 plus cosine alpha over 2. Tan alpha over 2, the same thing here, take a root. If we multiply the inside by 1 minus cosine alpha over 1 minus cosine alpha, or 1 plus cosine alpha over 1 plus cosine alpha, we establish these two identities as well. So let's look at some proofs. All right, starting with sine of 2 alpha, we want to prove that it's 2 sine alpha cosine alpha, and we're going to use the fact that sine of alpha plus beta has this formula. So what if we use, instead of beta, we put alpha. So sine of alpha plus alpha. So if I replace this with alpha, then I'm going to replace this with alpha. I'm going to replace this with alpha. And that is sine of alpha cosine alpha sine alpha. These two are identical, and it proves the identity. For cosine to alpha, we're going to do the same thing. We're going to write that as cosine alpha plus alpha. So in this formula, we are going to use alpha plus alpha, which means we're going to replace the beta with alpha. When we do that, we get cosine alpha, cosine beta changing to cosine alpha minus Sine alpha sine beta becomes minus sine alpha sine alpha. So now what do we have? Cosine squared alpha minus sine squared alpha. We proved this identity. Now, if we replace sine squared with 1 minus cosine squared, and we can write this as cosine squared minus 1 plus cosine squared, and it proves that it's equal to 2 cosine squared alpha minus 1. If I go back to that, and I change this time this one to 1 minus sine squared alpha. Now it proves this identity. So cosine 2 alpha is cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. It has 3 different ways of writing. Now, I can use this formula to find sine squared. Let me write it at top so you see that. Two sine squared alpha is 1 minus cosine 2 alpha. So I move this one this way, this one this way. Now if I divide both sides by 2, I establish this identity. Sine squared is 1 minus cosine 2 alpha over 2. If I move minus 1 here and make this plus 1, and now if I divide by 2, I establish this identity. So sine squared is 1 minus cosine 2 alpha over 2. Cosine squared is 1 plus cosine 2 alpha over 2. What about tan squared? Tan squared, as always, is sine squared over cosine squared. So tan squared is sine squared over cosine squared, which means this over that 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. So again, divide sine squared by cosine squared, and it establishes tan squared alpha is 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. So those are the proofs. Now, in all of those cases, I can change the 2 alpha to alpha. Then I got to change this to alpha over 2. All of these cases. Or you might even say, if I let this one be theta, then this one is what theta over 2. You can go that way. And so it establishes the following. Tan squared of alpha over 2 is 1 minus cosine alpha over 1 plus cosine alpha. Cosine squared of alpha over 2 is 1 plus cosine alpha divided by 2. Sine squared of alpha over 2 is 1 minus cosine alpha divided by 2. So we proved all of these, and we are going to use them to establish more identities or solve problems. Tan of 2 alpha, we have this formula. Tan of alpha plus beta has this formula. So if I change the beta to alpha, becomes tan of 2 alpha. So change the beta to alpha. So you get tan of alpha plus alpha. It's tan of alpha plus tan of alpha, 1 minus tan of alpha, tan of alpha. So this is 2 tan alpha, and this is 1 minus tan squared. So we established tan of 2 alpha is 2 tan alpha over 1 minus tan squared alpha. Again, all you have to do is change this beta to alpha, and you can prove this. We've already looked at those three in the previous page. Therefore, if I want cosine of alpha over 2, I take a root. Same thing for this one, same thing for this one. And I put plus minus. And normally we look at the quadrant to figure this out. In the case of a tangent, if you look at this formula, and again, you can multiply this inside by 1 minus cosine alpha over 1 minus cosine alpha. Look at this. I'll give you a chance to look at this at home on your own, see what happens. And what if you multiply it by 1 plus cosine alpha, 1 plus cosine alpha? It establishes these two, this one and this one. That's tan of alpha over 2 is 1 minus cosine alpha over sine alpha, or sine alpha over 1 plus cosine alpha. And so the bottom line is we have these identities, the half angle identities. We have plus minus for the square roots. And how do we figure out the sine, the quadrant? In this case, we don't have to worry about the sine. But on a normal basis, if you have sine and cosine, tangent would be the ratio of the two. That would be the fastest way to calculate it. That's another way of establishing this. If you divide this one by this one, you can see that. So the plus and negative sign is determined by the quadrant of the angle alpha over 2. So for example, sine squared alpha over 2, we said is 1 minus cosine alpha over 2. So as I said, tan alpha, you can write sine over cosine. Also, sine of alpha is 2 sine alpha over 2 cosine alpha over 2, because sine of 2 alpha, let me write that for you. This is, everybody remembers, we just proved that sine 2 alpha is 2 sine alpha cosine alpha. And if I cut this in half, I get alpha. Then I have to cut this one and this one in half. I get alpha over 2 in each case. So what we are saying is, let me erase that. Tan of alpha over 2, it is also 1 minus cosine alpha over sine alpha over 1 plus cosine alpha. So different ways of approaching it. And we're going to take it from there. All right. We have sine theta equals 3/5. Theta is between pi/2 and pi. And we want to find the exact value of sine 2 theta. And I'm reminding you that, for example, sine 2 alpha is 2 sine alpha cosine alpha. Cosine 2 alpha is cosine squared minus sine squared. This is one way to write it. There are other ways, as I mentioned, for cosine. So we want to find sine 2 theta and cosine 2 theta, where sine theta is given. So quickly, when we write the formula for that, which is 2 sine theta cosine theta, we have sine theta, so we need to find cosine theta. So we use the identity sine squared plus cosine squared is 1. Therefore, cosine is plus minus the square root of 1 minus sine squared. We plug in the sine is 3/5. When we square it, we get 16/5. So let's quickly do that. So this becomes 9/5. The difference 9/25, and this inside is 16/25, and it comes out of the radical as 4/5, so plus minus 4/5. So we have to choose either positive or negative, and the reason we pick negative because this is quadrant 2. In quadrant 2, cosine is negative. So all we have to do, just plug in 2 times sine theta, which is 3/5, cosine theta, which is negative 4/5, and we get negative 24/25. For cosine 2 theta, since we already have sine as well as cosine, it is easy to use cosine squared minus sine squared. So we're going to square cosine, which is negative 4/5, and then minus, we're going to square sine, which is 3/5. This is 16/25. This is 9/25. 16 minus 9, 7/25. Now we want to solve this equation. Cosine 2 theta is 2 minus 2 sine squared theta. Well, we know cosine 2 alpha. Alpha is a dummy variable. Could be 2x, could be 2 theta, doesn't matter. It has 3 ways of writing: cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. So to solve this, when we look at the right side, that it has nothing but sine, so we're going to change the left side also with something that has sine and nothing else. So cosine 2 theta, we're going to write it as 1 minus 2 sine squared theta. Again, why do we do that? We have 3 options. Why do we use the last option? Because the right side has only sine and nothing else. In this case, more specifically, sine squared. So the left side is changed to 1 minus 2 sine squared theta. Now, before we move anything around, we notice these two are identical. We don't have to move them. We just drop them from both sides. They have the same sign. So we are claiming 1 equals to 2, which can't be, and there is no solution. This is phi, which represents no solution. There is no solution. This is a Greek letter phi, which represents an empty set. Sine 2 theta plus cosine 2 theta equals 0. One way to solve this, we move one of them to the right. And now if I divide both sides by cosine, I get to tangent. If I divide both sides by sine, I get to cotangent. Either way will do the job. So let's divide both sides by cosine 2 theta. Left side, tan 2 theta. Right side, -1. So 2 theta, what is the tangent -1? The tangent is negative in the second and fourth quadrant. So it's -1. If we write 3 pi over 4 plus n pi, will do that. Pay attention to the fact we are dealing with tangent. If we are dealing with tangent or cotangent, the period is pi, not 2 pi. And therefore, if you wrote this, this is good enough. And we can establish all of it if we want it from 0 to 2 pi. Whereas in the case of sine and cosine, we have to write 2 of them in the appropriate quadrants. So right now, we're going to divide both sides by 2. This becomes 3 pi over 8. This becomes n pi divided by 2. That's a general formula, and you're done with general. But if they want it from 0 to 2 pi, then you have to go with n equals 0, 1, 2, 3. Why is it that we stop at 3 and we don't go to 4? Because if you put 4 pi over 2 makes it 2 pi, and it takes you a complete revolution beyond the answer, and it will repeat the answer. In fact, even if you make a mistake, just pay attention that if you put the next number, it is going to go plus 2 pi, and you don't want that. So in the first revolution, 0 to 2 pi, you're going to replace the n with 0. So you get this one. If you replace it with 1, pi over 2, so if I multiply the top and the bottom, just as an example, just, I do one of them so you see what that gives us. So if I use 1, I get 3 pi over 8 plus pi over 2. Now pi over 2, I can write it as 4 pi over 8. With 3 pi becomes 7 pi over 8. If I put 2, I get 3 pi over 8 plus 2 pi over 2, which is pi. And pi is 8 pi over 8. That gives me 11 pi over 8. And if I put 3, I get 15 pi over 8. I leave the last one for you to do it so you can do this on your own. I did the other ones. So there are 4 answers from 0 to 2 pi. All right, we want to write cosine to the power of 4 in a format that doesn't involve powers of cosine or sine. Powers of sine or cosine greater than 1. And cosine to the power of 4 is cosine squared to the second power. We use this formula, cosine squared is 1 plus cosine 2 alpha over 2. So we're going to replace this with this formula. Of course, instead of alpha, we're going to use theta. So we're going to use this formula. So we're going to write 1 plus cosine 2 theta over 2 quantity squared. We are going to square the parentheses. And when we do that, first and foremost, this becomes 4, okay? So we have 1/4 of whatever is at top. The top is 1 plus 2 cosine 2 theta plus cosine squared 2 theta. I'm assuming we are okay with that, and I'm going to rewrite what I've been writing for you all along. A plus B quantity squared is A squared plus 2AB plus B squared. Please note that everything is being divided by 4. It makes it easier to take this out, okay? Instead of writing 1/4 2 cosine 2 theta over 4 cosine squared 2 theta over 4, we just put the 1/4 out. And as you can see, we can distribute that. We don't have to, but we can distribute that. And the only thing that we want to change is this one because it has power 2. So we can distribute the 1/4, or you can do it at the end, it doesn't matter. But now the first one, so this doesn't change, this doesn't change. This one, we are going to use the same formula again. And cosine squared of 2 theta, assume 2 theta is alpha, so you want 2 times that. So this becomes 1 plus cosine squared of 2 times 2 theta divided by 2, which is 4 theta. So this, again, with this one, we are going to use the same formula again. And 2 theta becomes 2 times that, 4 theta. And we are done. We just apply the 1/4. 1/4 times 1/2 is 1/8. 1/4 times 1/2 is 1/8. So this is 1/8 plus 1/8 cosine 4 theta. We can add these two numbers, 1/4 and 1/8. Okay, so I can write this at the bottom so you can see 1/8 plus 1/8 cosine 4 theta. This is 4 theta. So 1/4 and 1/8, they add up to 3/8. And everything else remains unchanged. All right, we want to solve this equation, and as we read the question, we notice it's a familiar identity. So we write cosine alpha, cosine beta, minus sine alpha, sine beta at top of it. Then we write both formulas so we are reminded as to what's going on. And so this looks like this one, right? Cosine of alpha plus beta. So cosine of alpha plus beta, 2 theta plus theta. So this is alpha, this is beta, cosine of 3 theta is 1/2. Cosine of 3 theta is 1/2. Imagine cosine of x is 1/2, and cosine is positive in the first quadrant. The answer is pi/3, and it's positive in the fourth quadrant. It's 5 pi/3. And we added 2k pi. So pi/3, first quadrant, and a general format would be plus 2n pi or 2k pi. In the fourth quadrant, two pi minus pi over 3 gives us 5 pi over 3 and 2k pi. We divide both sides by number 3. Pi over 9 plus 2k pi over 3, 5 pi over 9 plus 2k pi over 3, and we are done if we want to answer the general format. If we want it from 0 to 2 pi, then we choose k to be 0, 1, and 2. So if we wanted to go from 0 to 2 pi, then we choose n to be 0, 1, n, or in this case, k, and 2. Why do we stop at 2? If you choose 3, 3 cancels out 3, and 2k pi, it's a whole revolution. It's a complete revolution beyond. Therefore, all the way to 1 less than that. 1 less than this number, if you will. In both cases. An object is propelled upward at an angle of theta, which is between 45 and 90 degrees, to the horizontal with an initial velocity of v sub 0 feet per second. If air resistance is ignored, the horizontal distance r, the range it travels, is given by 1 over 16 v sub 0 quantity squared sine theta cosine theta. Show that r can be also equal to 1 over 32 v sub 0 squared sine 2 theta. We want to establish that. We know that sine 2 alpha is 2 sine alpha cosine alpha. Therefore, if you look at this part, if we had it, number 2 would be sine 2 theta. Since we don't have it, it's half of sine 2 theta. So this is half of this, right? Based on sine of double angle. 1/2 times 1 over 16, the product is 1 over 32, and that's a proof. Find theta to maximize this range R. When we look at this, what can maximize this? If we could come up with the maximum value for a sine, as you know, the maximum value for a sine happens when sine equals 1, and sine is equal to 1 when the angle is equal to pi over 2. So 2 theta must be pi over 2. So again, maximum R happens when sine 2 theta is maximum, which is 1. And that happens when 2 theta is pi over 2. And theta becomes pi over 4. So the maximum occurs if the choice is pi over 4 or 45 degrees, at angle of 45 degrees gives us the maximum range. Use a half angle formula to find the exact value for sine of 22.5 degrees, cosine of 5 pi over 12. So let's stick with sine of 22.5 degrees. And we notice 22.5 is half of 45. So it's sine of 45 over 2. And 45 is one of those common arcs. Needless to say, this is in the first quadrant, and so is this one. So they are both positive. So maybe I write this. Quadrant 1, therefore, is positive. Same thing here. 5 pi over 12. Remember, 6 pi over 12 is pi over 2. It's less than that. Therefore, also this is in quadrant 1. And makes it positive. So that's why with the plus minus, we don't have to use the minus. For sine, we're going to use 1 minus cosine alpha over 2. We're going to use this one. So 1 minus cosine of 45 degrees over 2. So we're going to use this formula. And we know cosine is square root of 2 over 2. If I multiply the top by 2, and the bottom by 2, the bottom becomes 4, and the top is no longer having any fraction, becomes 2 minus square root of 2. And this 4, I can bring it out as 2. And this is the exact answer. Exact answer. Square root of 2 minus square root of 2 minus square root of 2. So this square root of 2 is inside this square root. For 5 pi over 2, we notice is 5 pi over 6 divided by 2. And 5 pi over 6, remember, it is also a common arc because it involves pi over 6. And cosine of 5 pi over 6. So we are going to use this one for cosine of alpha over 2 and a plus sign only because we established it's positive. Now, what is cosine of 5 pi over 6? First, let's discuss the reference arc for this. Pi over 6. So it's the same as cosine of pi over 6, which is square root of 3 over 2. But is it positive or is it negative? Since 5 pi over 6, it's in quadrant 2, and cosine is negative, so minus square root of 3 over 2. So I hope everybody is following that. The reference arc is pi over 6. So gives us the answer square root of 3 over 2. All we have to do positive or negative based on the quadrant. Quadrant 2 makes it negative. So this is a positive sign. The reason this becomes negative because cosine of 5 pi over 6, it's in the second quadrant, it's negative. If I multiply the top and the bottom by 2 as I did here, this becomes 2 minus square root of 3, and this becomes a 4, and the 4 comes out as 2. And that's the precise answer. Cosine alpha is given as negative 1/5. Alpha is between pi over 2 and pi, and we want to find the value of sine alpha over 2, cosine alpha over 2, tan of alpha over 2. So the very first thing is to establish the quadrant. When we divide both numbers by 2, this becomes pi over 4, this becomes pi over 2, and it's the first quadrant. So first we have to figure out the sign. For tangents, you don't have to, because after you find sine and cosine, you can divide the two and that gives you tangent. That would be probably the fastest way. But we have to establish whether they're positive or negative. It's the first quadrant. So sine, we use this formula with a positive. So square root of 1 minus cosine alpha divided by 2. And cosine alpha will be replaced with negative 1/5. So it becomes 1 minus negative 1/5, which makes it positive 1/5. With the 1 becomes 6 over 5. Or 3 over 5. Right? Because 6 we can divide by 2. Now, if I multiply the top and the bottom by 5, the bottom comes out. So the bottom comes out as 5. I'm multiplying this inside the radical. When I do that, 5 times 5 comes out of the radical as 5, but 3 times 5 remains square root of 15, and we are done. For cosine, I'm going to use the square root of 1 plus cosine alpha divided by 2. And I'm going to replace it accordingly. Now 1 with negative 1/5 is a 4/5. If I divide it by 2, I get 2/5. And simply put, you can multiply by square root of 5 over 5. The best course of action is to just show that right here. We're going to multiply by square root of 5 over square root of 5. The denominator comes out as 5 and the numerator becomes 10. Now, in order to find tangent, all you have to do divide sine by cosine. That is the fastest and easiest way. Obviously, the denominators are 5 and we can drop it. Square root of 15 over square root of 10, we can divide the top and the bottom by 5. Inside the radical becomes square root of 3 over 2. You can do that, right? This is like this, which is like this. And then I'm going to multiply this by square root of 2 over square root of 2. And I get square root of 6 over 2 as the final answer because it's rationalized. Cosine alpha is given. Alpha is between pi and 3 pi over 2. You want to find the exact value again. We don't worry about the tangent too much because when we get sine and cosine, the ratio is tangent. So we need to establish positive or negative. We're going to divide both by 2. This becomes pi over 2. This becomes 3 pi over 4. That puts us in the second quadrant. So we divide both by 2. Why? Because we want alpha over 2. In quadrant 2, we know sine is positive. And in quadrant 2, we know cosine is negative. So for sine, we use this formula with the plus sign. So square root of 1 minus cosine alpha over 2. So I'm not going to rewrite that. Square root of 1 minus negative 3 over 5 divided by 2. So I'm using this formula with the plus sign because we established in quadrant 2 sine is positive. So 1 plus 3 over 5 makes it 8 over 5. The numerator is 8 over 5. And if you divide it by 2, you get 4/5. I can bring the 4 out, becomes 2. And if I multiply right here, by square root of 5 over square root of 5, I get 2 square root of 5/5. For cosine, I'm going to use the negative sign minus the square root of 1 plus cosine alpha/2. I'm going to use this one with the negative because we established in the second quadrant cosine is negative. And square root of 1 plus negative 3/5 divided by 2. And I put a negative sign with a different color to emphasize that I'm using the negative one. So 1 minus 3/5 obviously is 2/5 divided by 2 makes it 1/5. And we are keeping the sign. So negative 1 over square root of 5. And again, right here, you can multiply by square root of 5 over square root of 5. And it gives you this answer. For tangent, we don't use, we can use any of these formulas. But the fact is we have sine and cosine, so let's just look at the ratios. That would be the fastest way. So sine over cosine. Sine is 2 square root of 5/5. Cosine is minus square root of 5/5. Again, can we use others? Yes, but this is the fastest and easiest. And obviously in the second quadrant, you end up with a negative value for tangent. So I hope you see that they cancel each other. Then 2 square root of 5 over minus square root of 5 is simply negative 2. It's a very simple calculation. All right, we want to establish the identity that sine theta is cosine theta times 4 sine theta minus 8 sine cube theta. Well, let's start with the more complicated side, which is the right-hand side. And let's notice that there is a common factor of 4 sine theta. So we're going to take the 4 sine theta out from the right side. So we get cosine theta times 4 sine theta. And then what is left in the parentheses is 1 minus 2 sine squared theta. So I hope everybody can see what I've done. I am factoring 4 sine theta from the parentheses. And I'm going to rewrite this so everybody can see what we have here. We have a 4 sine theta cosine theta. So we have sine of 2 alpha is 2 sine alpha cosine alpha. If it was 2, would be sine 2 theta. Since it's 4, there are 2 of it. So this is 2 sine 2 theta. And I hope you remember this is the definition, one definition of cosine 2 theta. So the first one is 2 sine 2 theta, and the second one is cosine 2 theta. So what you really are looking at is, let's just write it here. So I want to be clear without the parentheses, 2 sine 2 theta, cosine 2 theta. And if you compare this to this, imagine this is alpha, then this would be sine of 2 alpha. So sine of 2 times 2 theta, which makes it sine of 4 theta. Which is the left-hand side, okay? Right-hand side, left-hand side. You want to establish this identity, and again, the right-hand side is more complicated. we are going to start with the right-hand side, and we're going to write ln of 1 plus cosine 2 theta minus ln of 2 is the same as ln of 1 plus cosine 2 theta over 2. So right-hand side is 1/2 ln. Because of this, we get this one, and I'm going to remind you, I hope you remember, I went over this concept last time, and you really need to remember that. Remember, for example, ln of x over y is ln x minus ln y, and we are going this way. Now, also, this becomes the exponent of a log, and I'm going to remind you of that one. For example, if we have a log, let me use a different color so you see what I'm talking about here. If we have a log x to the power of n becomes n log x. Let's say the base is a. We are going this way now. That's what this is. So n becomes a coefficient. If it's a coefficient, you can make it the exponent. So 1 plus cosine 2 theta divided by 2 to the power of 1/2. And as you remember, cosine squared is 1 plus cosine 2 theta over 2. So this expression is cosine squared theta. And when you raise this, remember cosine squared theta means, again, I want to make sure that we understand what's going on. This means cosine theta to the second power. And then to the power of 1/2 just gives you cosine theta back. And it's ln of absolute value of cosine theta. And that is the left-hand side. And that's the proof. All right. Cosine 2 theta plus 5 cosine theta plus 3 equal to 0. We have 3 ways of writing cosine 2 theta. And we notice we have 5 cosine theta, then we want this one to be involved with cosine only, and that's why we use the second one. So I hope you see we have 3 choices. Why do we choose this one? Because of the rest of it. So we have 2 cosine squared theta plus 5 cosine theta, and these 2 add up to positive 2. It's just a matter of factoring. I'm going to assume everybody can factor. This 2 is a prime number, so it's 2 and 1. 2 is also a prime number, it's 1 and 2. So it's very simple. This tells you cosine theta is negative 1/2, and this tells you cosine theta is negative 2. Needless to say, this has no solutions, right? Cosine can't be negative 2. Cosine is between negative 1 and 1. For negative 1/2, remember 1/2 is pi over 3. Because it's negative, it's in the second quadrant, pi minus pi over 3, and it's in the third quadrant, pi plus pi over 3. So again, I want to make sure everybody understands what's going on. This one, cosine theta equals 1/2, reference arc equals pi over 3. Because it's negative, we say pi minus pi over 3 here, and we say pi plus pi over 3. And this, no solutions. All right, we want to establish the identity. cosine u is using this one. This will be 2 sine 2u. Again, we are looking at the left-hand side. And this is cosine of 2u. Okay, look at those identities, look at this identity, and you have 2 sine cosine. 2 sine cosine is sine of 2 alpha. So sine of 2 times 2u. So this is this, which makes it 4u. All right, we want to establish this. We start with the left-hand side, which is more complicated. We're going to change everything to sine and cosine, which means this is cosine over sine, this is sine over cosine. And we can take a common denominator, or we can just multiply by sine, cosine. Either way is fine. So I'm going to show you this method of taking a common denominator. I would multiply the top and the bottom by sine theta, cosine theta. That is faster. But if you want to take a common denominator, sine theta, cosine theta, this becomes cosine squared minus sine squared. This becomes cosine squared plus sine squared. So if you take a common denominator, you can drop the denominators. The top, cosine squared minus sine squared, remains, and the bottom is 1, right? What is cosine squared minus sine squared? Cosine of 2 theta, and that's the proof. Show that the area of an isosceles triangle is A equal to 1/2 S squared sine theta, where S is the length of one of the 2 equal sides, and theta is the measured angle between them. So here's the side S, and here's the angle theta. And we know the area in general is 1/2 base times the height. So all we have to do, figure out what's base, what's h, and we find the answer. So if this is the base, this is half of it. If this is theta, then this is half of it. And we are looking at this half, let's say. So we are looking at, let's say this half or the other half, it doesn't matter. So this is theta over 2. So theta over 2, what is cosine of theta over 2 is h over s, the adjacent over the hypotenuse. And so what is the height? Cosine theta over 2 times s, right? The cross product. Remember, this is cosine theta over 2 over 1. If you want, you can write it as cosine theta over 2 over 1. That's the cross product. What is sine theta over 2? This is theta over 2. Sine is the opposite, b over 2 over s. And therefore, b over 2 is s times sine theta over 2, and then b is 2 times that. So I hope you can establish this. Let me just quickly. So I'm going to write sine theta over 2 over 1, and this is b over 2s. We do the cross product. And so just plug in, instead of base, 2s sine theta over 2, instead of the height, s cosine theta over 2. And as you can see, we have 1/2 s, and s is s squared, 2 sine theta over 2 cosine theta over 2. And this is a sine of 2 times theta over 2, this part. which makes it sine theta. And believe it or not, this is the proof. A rectangle is inscribed in a semicircle of radius 1. The radius is 1. With one of its sides on the diameter of the semicircle. Find the dimensions of the rectangle to get maximum area. Also find the maximum area. So first express the area as a function of theta. Well, we know the area is the length times the width. The area is the length times the width. So if this is x, the length is 2x and the width is y. So 2x times y. Length is 2x, the width is y, 2xy. So this is theta. Let's calculate sine of theta and cosine of theta. Sine of theta is the opposite over the hypotenuse, and this is 1. Radius 1. And cosine theta is x over 1, or x. So we're going to replace that to cosine theta, sine theta. And we know this is equal to sine 2 theta. So that's the first part. The maximum occurs when sine is maximized. And sine is maximized when it's equal to 1. When would it be equal to 1? When the angle is pi over 2, when 2 theta is pi over 2. And that means theta must be pi over 4, or 45 degrees. So what is the area? 2 times x times y. X is cosine theta. Cosine of 45 degrees is square root of 2 over 2. Y is sine theta, which is the same thing, square root of 2 over 2. Okay, so x is cosine pi over 4. Y is sine pi over 4. Both of them become square root of 2 over 2. So we plug in 2 cosine and sine. Each one is square root of 2. And the answer is, I hope you realize it's 1, because this is 2. So the numerator is 2 times 2, 4. The bottom is 2 times 2, 4. We want to develop the formula for sine of 3 theta, and we know that sine of alpha plus beta. So we're going to replace one of them with theta, one of them with 2 theta. So if we take this one to be 2 theta and this one to be theta, then sine of 2 theta, cosine theta, plus cosine of 2 theta, sine theta. Now sine 2 theta and cosine 2 theta, we're going to change them. This one becomes 2 sine theta, cosine theta. This one we can write it, for example, cosine squared minus sine squared. So this is this. This one is this. And we are going to multiply, and we get, this one is 2 sine theta cosine squared. This one we distribute, plus sine theta cosine squared minus sine cubed. And we can combine these two into 3 sine theta cosine squared. And we are done. We want to establish sine of 2 theta, cosine of 2 theta, and so on and so forth when sine theta is 1/6 and theta is between 0 and pi/2. So we need to find cosine theta because we know, for example, sine 2 theta is 2 sine theta cosine theta. So from the sine, let's find cosine using plus minus the square root of 1 minus sine squared theta. And we are plugging in. I'm going over this pretty fast because it should be very straightforward. And 1/6 squared is 1/36. 1 minus that. So this is 1/36. And 1 minus that is 35/36. And we get plus minus the square root of 35/6. And why are we using positive? Because this is quadrant 1. This is quadrant 1. Everything is positive. So we plug in into sine 2 theta, 2 sine theta, cosine theta. We replace the sine with 1/6 and cosine with square root of 35/6. And as you can see, the numerator is square root of 35, the bottom is 18, and we are done. Cosine 2 theta, we can use any of those formulas because we have sine and cosine. Therefore, let's go with cosine squared minus sine squared. So we square each one. The first one is 35/6. 35/36. And the other one is 1/36, which gives us 34/36. We can drop a common factor of 2, 17/18. Now, this is the first quadrant. The half angle is also in the first quadrant, which makes sine and cosine, both of them positive. So for sine, we're going to use the positive 1 minus cosine alpha/2, or theta in this case. So we use square root of 35/6. I can multiply if I multiply this one by 6/6, I get, let me put this as 6 minus square root of 35 at top, and this changes to 12. Now 12 is a 4 times 3, 4 comes out as 2. And that's what you get. So again, 12 under the radical, which is 3 times 4, and the 4 comes out. All right. For cosine, we use the same thing with the plus sign. And I hope you realize, and I'm not going to go over that, but I hope you realize when you have this answer, compare this one to this one. This negative just becomes positive. So the same answer goes here, and this negative changes to plus. I highly recommend you try this, see if you come up with this answer. Let's look at the last question. We want to establish this identity, and the left-hand side seems to be more complicated. We take a common denominator of cosine alpha minus sine alpha times cosine alpha plus sine alpha. We multiply these two minus these two. When we multiply this one by this one, they are identical. We square them, the same thing here. So let's square this one. Cosine squared plus 2 cosine alpha sine alpha plus sine squared minus, let's square this one, cosine squared alpha minus 2 cosine alpha sine alpha plus sine squared alpha, and we are going to distribute the negative sign. So this is the left-hand side. We're going to distribute the negative sign, so we get minus cosine squared alpha plus 2 cosine alpha sine alpha minus sine squared. So therefore, we can drop this one and this one. We can drop these two, and we can add these two to make 4 cosine alpha sine alpha. And the denominator is cosine of 2 alpha. Notice the numerator, if we had if we had 2 here, cosine alpha sine alpha or sine alpha cosine alpha makes no difference. This would be sine 2 alpha, but since we have 4 of them, there are 2 of them. This is 2. You can think of this as 2 times 2 sine alpha cosine alpha, and this is sine 2 alpha. There are 2 of them, and this is 2 tan alpha, and that's the final answer.